Hello there, Gregory Carlson here for College Algebra, Section 3.2. So let's look back at that synthetic problem we just did, synthetic division. We had this number right here, negative 4x to the third, blah, 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 divided by x plus 3. And this is equal to this. Do you agree with me on that? We did this divided by this, and we got this as the answer. So this amount is equal to this amount. So what I'd like you to imagine is, if I multiplied this by x plus 3, I would have x plus 3 in parentheses times all of this in parentheses. The x plus 3 would cancel, and I would just have a remainder. So in other words, I'd have x plus 3 times this reduced polynomial plus a remainder. And that's where this comes from. This f of x equals x minus k q plus r. They want us to rewrite this expression right here with a root of 3. They want us to rewrite it in this form. So that's going to be pretty easy to do. So here we go. Because they went ahead and gave me the root, we just go ahead and put a 3 right here. Okay? So we don't have to do the opposite sign or anything. Let's write in our numbers 6, negative 3, negative 10, negative 1. And you need a placeholder. We don't have a constant term, and you do need one. So you need a placeholder if you're missing an x value, or you need a placeholder if you don't finish with a constant term. Okay, now we play our game. Bring down the 6. 3 times 6 is 18. Add this down. 3 times 15 is 45. Add these. 3 times 35 is 105. Add those down. 3 times 104 is 312. And add those down. So there's the remainder right here. So let's rewrite f of x. F of x is equal to x minus 3. Here's where you have to flip the sign. So it's x minus k, so x minus 3, times our reduced polynomial. So here's the constant x, x squared, x to the 3. So this is going to be times 6x to the 3 plus 15x squared plus 35x plus 104. And then you close your parentheses, and then we just add our remainder, which is 312. Okie dokie, so that's our answer. That car was very excited. I don't know if you heard that, but there was a car that just went by who was very excited that we got the answer. Anyway, so here you go. That's in the form x minus k times the polynomial that would divide cleanly plus our remainder. So as you can see, if you divided this by x minus 3, you would, do I want to say that, or is that confusing? If you divided by x minus 3, the answer would be in this form, where you just get your polynomial and then the remainder divided by it. But this is another way to write it, as if we've kind of factored it out. Anyway, let's keep pushing ahead. There's something really neat you can do with synthetic division. Check this one out. We have this really long polynomial, and they want to know what happens if we plug in negative a third. If we plug in negative a third every time we see an x, what answer are we going to get? And that's going to take forever to figure out, because we're going to have to do a bunch of fraction math and fractions times themselves. What a mess. But luckily, the remainder theorem says, if you divide a polynomial like this, if you divide it by x minus k, then the remainder of that is equal to f of k. That's really cool. So in other words, if we divide this by x minus k, in other words, here's our k value, negative a third, and we do synthetic division, the remainder is going to be the answer. So watch. 3, negative 23, negative 5, 4, 5. And we're going to do synthetic division. So here we go. Make sure I didn't miss a placeholder. Nope, they're all there. So bring down the 3. Negative a third times 3 is negative 1. Negative 23 minus 1 is negative 24. Negative a third times negative 24 is a positive number. 24 divided by 3 is 8. Add these down. Negative a third times 3 is negative 1. Add it down. Negative a third times 3 is negative 1. add it down. And so we get a remainder of 4. And so because of the remainder theorem, it's really cool. F of negative a third, equals 4. So the answer is 4. So that's kind of a result from this. When you, because this is x minus a third, when we plug in a third for x, we get a third minus a third. So that's 0. 0 times all of this is 0. So the answer is just the remainder. Do you see how this is related to this theorem? We plugged in a third, and we got a third minus a third, which is 0, times this is 0. So that means that when we plug in this number, the remainder is our answer. So we just saved a whole bunch of fraction headaches. And you can do this for any value with the polynomial just by doing synthetic division. So let's see. It says determine if the given k is a 0 of the function. So if we plug in negative 6 into this, is it going to equal 0? So obviously you could plug in negative 6 and crunch it all out, but who has time for that? Instead, let's just do synthetic division and see what our remainder is. This is a 0 of the function if our remainder is 0. So our coefficients are 1, 8, 9, 19. And make sure you don't miss a placeholder. Now let's play our game. Bring down 1. Negative 6 times 1 is negative 6. Add those together to get 2. Negative 6 times 2 is negative 12. Add those together, to get negative 3. This times this is 18. Add these together and you get negative 1 as our remainder. So we can see that f of negative 6 is equal to negative 1. And so therefore, no, it is not a 0 of the function. So that's that. We have one more problem to go, and I think we can finish it in this part. So determine if the given k is a 0 of the function. So is 2/3 going to be a 0? So we're going to plug in 2/3 into this function. And if our remainder is 0, you could plug it in and just see if it's 0. But we're going to use synthetic division and see if our remainder is 0. So our k value is 2/3. And our coefficients are 3, 2, 0. You see that? Because I don't have an x squared term. So there's a 0 placeholder. Negative 1 and 5. So that came from here. Now we play the game. Bring down the 3. 2/3 times 3. The 3's cancel, so you get 2. Add those together to get 4. 2/3 times 4 is 8 over 3, because you just 2 times 4 is 8. Add that up, it's still 8 over 3. 2/3 times 8 over 3 is 16 over 9. So negative 1 plus 16 over 9 means taking away 9 over 9. So 16 minus 9 is going to be 7 over 9. We multiply fractions again, so numerator times numerator is 14. Denom times denominator is 27. And 5 plus 14 over 27 is going to be some number. But it's obviously not going to be 0. So our remainder is not 0, so let's see what this is. Let's do 5 times 27. 135. So 135 plus 14 is 149. So we get 149 divided by 27. So obviously that's not 0. F of 2/3 is equal to 149 divided by 27. So no, 2/3 is not a 0. So that's how you can use synthetic division to find f of a number to save some time without having to crunch in the whole thing. If this was really, really long, a really long polynomial, maybe of degree 12 or something with 12 or 13 terms, then this is a lot faster than trying to crunch in all of those numbers and figure out what it is. So that's the introduction to synthetic division. I hope you like it. I think it's kind of fun. And just remember the connection that we had on the previous page. Just remember the connection between this idea of finding f of the value and the fact that it's a result from this right here. Because we just found f of 2/3. So it would be 2/3 minus 2/3, which would be 0, times this is 0, so the result is just the remainder. That's how we know that f of whatever was equal to our remainder. So I hope you enjoyed 3.2. We are going to be doing some more synthetic division in 3.3, and I will see you there.